Hello students. So next question is the rate constant for the decomposition of hydrocarbon is 2.418 multiplied by 10 to the power minus 5 per second at 546 Kelvin. If the energy of activation is 179.9 kilojoule per mole, what will be the value of pre-exponential factor? So what you have to do is you have to first write down all the variable and write the Arrhenius equation in the form of Arrhenius equation. So what is Arrhenius equation? K is equal to AE minus EA by RT. Now we will write in the form of natural log, that is ln K is equal to ln A minus EA by RT, and further we convert it into log because we have to find out the value of A. So log K is equal to log A minus EA by RT multiplied by 2.303. Now we have to find out log A value. So log A is equal to log K minus EA by 2.303. Here ln K, for converting ln K to log K, we multiply by 2.303. So that log K value is obtained at the base 10. Now we put all the value here. Now putting all the value, that is log A is equal to log K value. Here K value is given log 2.418 multiplied by 10 to the power minus 5 minus EA value. What is EA value? 179.9 kilojoule. 179.9 multiplied by 1000 because it is in kilojoule, divide by 2.303 multiply by R, that is gas constant 8.314 multiply by temperature. How many temperature? How much temperature is 546. Now we will solve this. First we write this in. First we write here all the variable correctly, as it create confusion. Log 2.418 2.3. Now here we calculate this. Here log A log, we will calculate this log 2.418 plus 5 log 10 minus 5 plus minus 179 upon 99.9 is given, so here 9 is more, divide by 10454.34. Now after calculating, here value log A is equal to log 2.418, that is 0.383 minus 5 log 10. Log 10 value is 1, so this will become minus 5. Here plus sign is there because log A moving on left side and log A right side, or you can say moving minus EA by RT 2.303 to left side, it will become plus sign. So here plus sign is there. Now after calculating, it will become 17.21. Now log A is equal to 0.383 minus 5 plus 17.21. Now here log A become minus 4.617 plus 17.21. Now after solving, it will become log A is equal to 12.593. Now we will take the antilog of 12.593 so that A value is calculated. So A is equal to antilog of 12.593. Now here how we calculate? We take antilog of 0.593 plus 12. We will write like this, or we can, for simplification, we will write like this. Now that will become equal to A is equal to antilog 0.593 multiply by 10 to the power 12. Now we calculate the value of antilog of 0.593. This will become, now after calculating antilog of 0.593, we get value 3.91 multiply by 10 to the power 12. And here question asked about pre-exponential factor, that is unit is in second inverse, so answer will be in second inverse. So this is how you will solve this question. So next question is, consider a certain reaction A that is forming product with K 2 in multiply by 10 to the power minus 2 per second. Calculate the concentration of A remaining after 100 seconds. if the initial concentration of A is 1 mole per liter. So from the question it implies that per second is there, so reaction is in first order reaction. So first order reaction formula, we know that K is equal to 2.303 divided by T log initial reactant, that is R naught, upon reactant at any time T. So here K is given, that is this 2 multiplied by 10 to the power minus 2, and initial reactant is given, that is 1 mole per liter, and time is given, that is 100 seconds. Now we will put all the variable in formula. Here 2 multiplied by 10 to the power minus 2 is equal to 2.303 divided by 100 second log initial reactant, that is 1 mole, upon reactant at any time T. Now we have to calculate the concentration of reactant at any time T. Any time, or you can say at 100 second. So here 2 multiplied by 10 to the power minus 2 is equal to 2.303. Here we can write in upward 10 to the power minus 2 log here log 1 minus this move to upward side and become minus, as we know property log 1 minus log R. Here 10 to the power minus 2 cancel out, and here also 10 to the power minus 2 cancel out. So what remaining? 2 upon 2.303. Here log 1 value is 0 minus log R. So now here minus log R is equal to 2 upon 2.303. Now this negative sign we move to left side so that log R become positive. So log R is equal to 2 upon 2.303. This is negative sign, move towards the left. So log R is equal to minus 2 upon 2.303, that is after solving become minus 0.8684. Now we have to calculate the anti-log of 0.8684 because this is in negative sign. So log R become equal to anti-log, so R is equal to minus 0.8684, and this is anti-log. Now anti-log of minus 0.8684, that after calculating it will become, now we calculate anti-log of minus 0.8684. So after calculating it will become 1.354 multiplied by 10 to the power minus 1. So concentration of reactant at 100 second will be equal to 0.1354. Now this is the answer. It's very easy, just you have to put all the variable in the formula of first order reaction. Next question is, sucrose decomposes in acid solution into glucose and fructose according to the first order rate law. With t half 3 hours, what fraction of sample of sucrose remain after 8 hours? So we have to calculate the fraction of sample of sucrose after 8 hours, and reaction is in first order. So first of all we will write what is given, that is t half is equal to 3 hours, and fraction of sucrose remain after 8 hours, that is time, total time is 8 hours. Now you have to calculate the fraction of the sample of sucrose after 8 hours. So what is first order reaction? That is K is equal to 2.303 upon T log R naught upon R. Here this is initial concentration, and here concentration of reactant at any time t. This is the formula, and from the formula we conclude that this is the fraction of sample. We can write this in the form of fraction. So we have to calculate this one. So here K is not given, so we have formula T half is equal to 0.693 divided by K. So from this formula we can calculate K is equal to 0.693 divided by 3R. So from this K is equal to, so we get 0.231 R. Here again we put all the variable in equation, that is K is equal to 0.231 is equal to 2.303 upon T, total time is 8 hours, log initial concentration upon concentration at any time t. Now we take log in this side, that is log R naught upon R is equal to 0.231 multiplied by 8 upon 2.303. So after solving, how much we get? Log R naught upon R is equal to, so after solving this will become 0.8024. Now this is the log value, and if we convert it, this will become anti-log. Anti-log 0.8024. This is antilog. Now next, r naught upon r is equal to antilog of 0.8024, we get 6.345. Now this is the initial upon final concentration at the time t, at any time t. So we have to calculate the fraction of molecule now. Here the fraction of sucrose we have to calculate after 8 hours as it is given. So here you see the equation that here fraction of compound is remain after 8 hours. So here fraction of sucrose after 8 hours is you have asked. So suppose initial concentration is r naught and after 8 hours the concentration will become r. So if we have to find out the fraction of molecule after 8 hours, so it will become, the reaction will become r by r naught, means final reactant at particular time upon initial reactant. Similarly here initial reactant is given and final reactant at the particular time is this, and we have to calculate the sample of fraction of sucrose after 8 hours. So it will become reverse, that is r by r naught. As we have discussed here, so this will become inverse 1 upon 6.345. So after calculating this, the fraction of sample, we get r upon r naught is equal to 0.158. So this is the sample of fraction of sucrose after 8 hours. So this is the answer. So this is how you will calculate this. And if you have any doubt regarding this question or previous question, you can ask me in comment section, and like and share with your friends, and thank you for watching. Keep learning.